Hi everyone, in this video I will try to decipher the bouncing or vibration metric that Formula One has implemented in order to protect the health of Formula One drivers. So as you know, the current generation of Formula One cars make use of a lot of ground effect and as a result have to run very stiff suspension. Some cars, especially like the Mercedes, suffer from porpoising, where the vehicles will violently hit the ground, and as a result, quite some drivers have voiced their discomfort after races. Drivers like Lewis Hamilton. This has led to certain theories floating around that it was maybe something that was that maybe for Mercedes, in order to improve their competitiveness, asked their drivers to really try to highlight the issue, and that many there are many articles where people are saying, well, Mercedes have Mercedes instigated this, but it's going to backfire. It is a valid interpretation. It is possible, although I don't think it is purely done by Mercedes for a performance benefit. So I mean, the theory is that they were maybe hoping that FIA would introduce a minimum ride height regulation, which would be quite easy to police, and then as a result, that would, on the one hand, solve their purposing issues, and on the other hand, cause everyone else to also raise their ride heights and bring Mercedes closer to the Red Bull and Ferrari. So this is possible, but I don't think the drivers, that's not my interpretation, because I think it wasn't just the Mercedes drivers who were complaining. It was also, I think, Pierre Gasly from AlphaTauri, and I think there were also some other drivers. So it's definitely not just the Mercedes drivers. And if you look at how some of the onboards, but also the video of the cars driving down the track, it does really look quite violent. So it's not really a surprise that the drivers are complaining. Hazardous levels of vibration to the body is a real threat. It can have long-term health consequences, and as a result, there are a lot of standards out there, regulations put in place to protect employees in normal industry, to protect them from long-term detrimental health effects from too much exposure to vibrations when operating heavy machinery, dump trucks, things like this. And so there has been, when the idea was mooted, I was thinking, oh, well, that's actually kind of coming closer to an area of work that I was previously involved in, which is looking at comfort. So there are, some well-known standards out there, such as from ISO 2631-1, which looks at, the human body's sensitivity to vibrations in different frequencies, different directions, and so there's a well-known phenomena that due to the internal resonance frequency of the human gut being between 3 and 9, that there's a well-known issue of choppiness, that humans are more sensitive to this 3 to 9 hertz vibrations in the vertical direction, and so there's different frequency weighting filters and so on, developed by ISO to kind of put a importance weighting for vibrations of different frequencies. So I was thinking, oh, okay, cool. FIA will probably implement something like that, and they're also well-known standards as to what constitutes a hazardous level of vibration. And so I've put some examples of that here. So for example, there's some there are regulations put in place by governments to protect people. So there's this like eight metric, eight meaning 8 hours. So 8 hours of work. So they're saying the if the exposure value is higher than 0.5, then employees should introduce technical and organizational measures to reduce the exposure. And there's a exposure limit value of 1.15, which should not be exceeded. But this is for 8 hours of work. And so you can see this graph on the right where what it's saying is that the longer the exposure time, the lower the exposure, the lower the acceleration level is allowed to be. So if we look at like 1.3, which is 1 hour 30 minutes, which is roughly the length of time of a typical Formula 1 race, you can see that the exposure limit is around 2.6 meters per second squared, and level at which some action needs to be taken is about 1.2. And over here, this is these are some the frequency weighting thing that I was talking about. So surprise, Formula One did not actually implement that. They implemented something quite different. And recently, this has been at least part of the metric has been leaked online, and so this is what this leaked on autosport.com, and various other places. So if we read through it, it says the definition of this aerodynamic oscillation metric. So they use external accelerometer, which is close to the center of gravity of the car, and the signal which is outputted by the accelerometer is this G-vert SDR external COG. And that will be used to calculate the metric, this AOM, aerodynamic oscillation metric, which is a representation of the energy associated with instances of large vertical acceleration, and is expressed in joules per kilogram per 100 kilometers with the following equation. And so when I looking at this, when you look at the word energy, so I was thinking, well, kinetic energy would be, the well-known formula half times mv squared. This looks a little bit like that, but then if you dig into it, it is actually a little bit different. And so if you read this, so 100 divided by 2 times the distance of AOM, so the total length of the section of the track used for this calculation in kilometers, and then in brackets delta t, so a sample time. So I think you have to imagine over a whole lap they would take many different samples, and then what they're doing is for each time sample they're calculating something and then making a summation. So then they're doing summation 9.81, which is 1 g in meters per second squared. Then they're doing something funny here. So they're taking the absolute value of the accelerometer, they're subtracting 3 from it, and then they're multiplying it by 2 different rect functions. So and the thing is, they only give the first one. They only give the rect 3g definition. They don't give the rect loop definition. But what they're saying is with the rect 3g that if x is less than 3, it becomes 0. If it is 1, it is 3. And if, and it's 1 if x is equal or greater than 3. So what this means is that if the for anything that is less than 3 Gs absolute, they just toss it out. It becomes 0 because the rect 3G becomes of this value becomes 0 if it is and I think actually looking at this they probably missed an absolute sign in this bracket. Oh wait, no, they didn't. Sorry, they didn't because it's down here. Absolute value of x less than 3. So yeah, so what I was saying is correct. So anything that is less than has an absolute value less than 3, they just toss it out, and then if it is greater than 3, then they do take it into account. So yeah, it's just multiplied by 1. But then what is unknown is this rect loop term. So I was trying to figure out from the units whether the rect loop actually could be something funky. But it seems not. So like trying to figure out the units. So 100 divided by 2, well, it becomes 50, but it's dimensionless in terms of units. So then the distance is in meters, or it could be in kilometers. Did they say? Oh, okay. So I messed up. This is actually in kilometers. So they do say, okay, DAOM is in kilometers. So I slightly messed up here. It's actually 1 over kilometer. It's 1 over 1,000 meters. It's also, in terms of units, it's also like meters. So delta t, that is in seconds. The vertical acceleration, that's in meters per second squared, and then there's this rect loop thingy. And that is all equal to joules per kilometer, per kilogram per kilometer. And so taking this out, the first portion out, so second, the second square becomes second due to the second which was outside, and then so that becomes meter per second, and then that becomes squared, and then you're left with this rect loop thing on the right side. The 1 over meter that eliminates one of the meters inside the bracket, so that becomes meters per second squared once again, and then there's the rect loop thingy. Joules is basically Newton times meter. So if you apply 1 Newton over 1 meter, that becomes a joule. Divided by kilogram times kilometer, and then so Newton divided by a kilogram, that is just meter per second squared. And so meter divided by kilometer also, so that eliminates 1 over 1,000. Well, it's also dimensionless. So it seems like the rect loop and loop, at least in terms of units, is dimensionless. So that doesn't really give us a lot of clues as to what is happening. But if we take the rest, so what I was saying is the way you have to interpret this metric is basically they're measuring the vertical acceleration, and the this rect 3g term is basically saying anything within 3 and minus 3 they just ignore and delete, and then wait a minute, did I mess up here? No, I didn't. Okay. Yeah. So they minus 3. So then it's only anything that is above 3 or smaller than minus 3 that they start to use to calculate the number. So like imagine everything within this gray bar just gets deleted, and then you just shift everything that is up, that was above 3 down by 3. And is that right? Oh yeah, it is right. Okay. Where I messed up on this diagram, where I messed up on this sketch is that because they did a absolute sign, the values below, they're flipped to the positive side. But anyway, in terms of the way you think about it, it doesn't really change things too much. So imagine taking the absolute value of this graph on the right, and then you end up, back with a meter per second squared, value. But okay, they turn it into joule per kilogram per 100 kilometer. So I very much think that this is an incomplete snapshot of the metric or the regulation. So I think the regulation will probably say something like the AOM metric must remain below a certain level. What that level is, we don't know. What the rect loop term is, we don't know. But it's most likely going to be something like, the AOM value must remain below X, for per 100 kilometers in order to protect the driver, which means that basically any team that is running their car too low and having too much bouncing will have to raise their car, which in the end very well might hurt Mercedes. It's definitely possible. Okay, so hope it was interesting, and till next time.